Welcome to qnawire.
In this question, we are to calculate the pH at equivalence point for titrating 0.200 molar solution of each of the following. So we have A is sodium hydroxide, B is hydroxylamine, C is aniline with 0.200 molar HBr. Okay. So HBr is a strong acid, and sodium hydroxide is also a strong base. So strong acid versus strong base will give equivalence points pH equals 7.0. So for this is a weak base, and this is a weak base. Okay, so titrating a weak base versus strong acid gives a solution of the conjugate acid at half the concentration at the equivalence point. Since equal concentration were used, we're gonna have at equivalence point, we're gonna have NH3 OH plus for this, and we're gonna have C6H5 NH3 plus for this. So and the pKa for this is around 5.96, and this is around 4.60 for the pKa of this, right? So now we can determine the concentration of H plus for each of them. So H plus for hydroxylamine will be 0.10 molar multiplied by 10 raised to power minus 5 times 5.96. Well, the way I got this equation is to say H plus concentration is equals to square root of Ka multiplied by concentration. Okay, so the square root of this altogether, so this is the concentration and this is the Ka. So the value for this would then be equals to 3.3 times 10 raised to the power minus 4, and then pH, which is a negative logarithm of H plus concentration, will give us 3.5. So it's going to be acidic. And the same thing also applies for the other one, aniline. So the H plus concentration for that will be the square root of 0.10, since half of it will be remain at the equivalence point, multiplied by the 10 raised to power minus 4, 10 raised to power 1. Sorry. What did I do here? Okay. Let me check something to make sure I'm doing it right. So the pKa of aniline Ka of aniline the Ka of aniline is 2.4 times 10 raised to the power minus 5. So this will give us 0.1 times 10 raised to the power minus 5 times 2.4 square roots so that is 0.00155. Then pH will be negative logarithm of the 0.00155. So that is 2.81. I'm just gonna check the pKa of hydroxylamine again to make sure I have it right. And that's just the answer.